Hearty hello from West Virginia, or hearty hello from somewhere. Okay, you are ready for joke of the day? Oh, I know you are. So let's get to it. Here's another one, a shout out to my father-in-law, Popsy, and he, he used to always say he wouldn't eat chicken. He would never eat chicken. He said it was foul. True story, actually, he never would eat chicken. But yeah, he worked in chicken coops and said, no, thank you. Not after working in the chicken coops. But he used to make a joke that it is foul. Anyways, so we are now going to take a look at dividing mixed numbers. And just like when we looked at multiplying mixed numbers and we said, I don't have any rules for multiplying mixed numbers. I got rules for multiplying fractions, but I don't have any rules for multiplying mixed numbers. So we said, let's just convert our mixed numbers to improper fractions and go with those old rules of multiplying fractions. Same thing here, guys. I have rules for dividing fractions, which frankly is a piggyback of my multiplication rules. We just copy, change, flip, and go back to multiplication. Same thing's going to happen here. Let's just turn these mixed numbers into improper fractions. Let's go back to the division rules, which isn't really a rule. We're just going to copy, change, flip, and go back to the real rule, which is multiplying fractions. See, it's all based on that one rule. And if you are in my math gang, because it's a fun gang to be in, when we multiply fractions, we're going to cancel the diagonals. We're going to cancel up and down. I know I look ridiculous. We're going to cancel up and down, and then we're going to shoot straight across. We're going to multiply across the numerator and the denominator. So see, it's really just one rule. So let's do that then. Let's take that first step, and let's turn into improper fractions, because I've got rules for fractions. I don't have any rules for mixed numbers. And then I'm going to go back to my division rules, go back to division steps, that is. And remember, that just simply means copy, change, flip. So let's try that out then. Let's take this first mixed number division problem, and I've got a 2 1/3 divided by 3 1/2. That means I'm going to take a 2 1/3, I'm going to divide it out 3 1/2 times. That's kind of a strange concept to understand. But what I do know is I have no rules for dividing mixed numbers. So I'm going to turn them into impropers by multiplying here and adding here. 3 times 2 is 6. 6 plus 1 will give me 7/3. Remember the superhero of fractions. We work awfully hard to keep that denominator. So 2 times 3 again is 6, plus 1 is 7. Here, multiply. 2 times 3 is still 6, plus 1 is still 7. So basically, I'm going to take a 7/3 and divide it by a 7/3, which you know... Oh, wait, just a minute. Oh, no, I'm sorry. 7/2. Please forgive me. Yeah, remember that superhero fractions? You need to keep it? Well, I messed up. I got to keep my denominator. So now, remember, this indicates I'm going to copy, change, flip, because I have no rules for dividing fractions. My only rules are for multiplying fractions. So I'm going to convert it into a multiplication problem by copying down the first one, changing it to multiplication, and flipping the second one. Now, I do have rules for multiplying fractions. Oh yeah, there it is. Cancel on the diagonals, cancel up and down, and then shoot straight across. So I'm going to check this diagonal. Aha! 7 goes into 7 once, 7 goes into 7 once. Check this diagonal for 2 and 3, nothing will go into those. But don't forget, always check up and down. 100% guarantee, 100%. If you will check up and down as well, when you multiply across, it's going to be simplified in the end. You don't even have to think about it. So 1 and 3, nothing cancels. 2 and 1, nothing cancels. I'm ready to shoot straight across. So 1 times 2 is 2, and 3 times 1 is 3. There it is. My answer is 2/3. And it's 100% guarantee that it is simplified. All right, let's try a couple more just to make sure we feel good with it. So remember, I don't have any rules for dividing my mixed numbers. I do have rules for fractions. So I'm going to convert these into impropers, multiply and add here. 2 times 3 is 6, plus 1 is, there's that 7/3 again. Multiply here, 7 times 3 is 21, plus 6 is 27. Keep that denominator, that superhero of fractions. But this is a division problem, and I still don't have any rules for dividing fractions. I got to go back to multiplying fractions. So I'm going to copy, change, flip, copy, change it to multiplication, flip the second, and now, like I said, bam, there it is. Canceling those diagonals. Nothing goes into 7 and 27. Nothing goes into 7 and 3. Wow, this rarely happens. I'm going to check up and down to see what happens. 7 and 3, nope. 7 and 27, nope. I am ready now to multiply straight across. So 7 times 7 is going to give me a 49, And 3 times 27 is an 81, and I'm a little terrified. I'm not sure if that'll simplify or not. Yeah, I am. Because remember, I canceled on the diagonals. I canceled up and down. I canceled everywhere I could cancel. That is a 100% guarantee. I don't have to think about it. That is simplified. 100% guarantee. All right, last one. Let's do this. So we are going to convert them to impropers. Multiply. 6 times 7 is 42. Add plus 1 is giving me a 43 over 6. Do it again. Multiply. 2 times 12 is 24. Plus 1. Plus 7 is a 31 over 12. But like I said before, this is a division problem, and I have no rules for dividing fractions. I only have rules for multiplying fractions. So I'm going to convert it into a multiplication problem. I'm going to copy, change, and flip. And there we are. Bam! Doing it again. Canceling on those diagonals, canceling up and down, and then shooting straight across. So on this diagonal, nope, 43 is prime, 31 is prime. Nothing I can do. But hey, this diagonal I can. 6 goes into 6 once, 6 goes into 12 twice. I'm going to check up and down just to be sure. 43 and 1, nothing happens here. 2 and 31, nothing happens here. I'm ready to shoot straight across. So 2 times 43 is an 86. 1 times 31 is a 31. And notice this time, because this is an improper, it's top heavy, I'm going to convert that to a mixed number. I didn't bother here, because that's not an improper fraction, nor did I here, because that's not an improper fraction, but this is. And I've said before, let me say it again, rule of thumb is, if you start with mixed numbers, like in this case right here, start with mixed numbers, I'm not going to end with an improper, I'm going to end with a mixed number. Now if you do not start with mixed numbers, then it doesn't really matter how you end. But without a doubt, if you start with mixed numbers, then you need to end with mixed numbers. So I'm going to divide up, and 31 goes into 86 2 times with a remainder of 24. Excuse me, 24. And I'm going to keep that superhero fractions. 62. Yeah, 24. And I'm going to check to see, will this simplify? Is there a number that will go into 24 and 31? Well, remember, 31's prime, so 31 had better go into 24, and it doesn't, so that is simplified, 100% guarantee. So I hope this helps with dividing your mixed numbers. Like I said before, I got no rules for dividing mixed numbers. I got no rules for multiplying mixed numbers. It all goes back to the basic fractions. So in both of those cases, with multiplying or dividing mixed numbers, you've got to turn them into impropers. Then go back to the improper rules. But again, I have no rules for dividing fractions. I have multiplication rules. So I'm going to copy, change, flip, and turn it into a multiplication problem. And then, oh yeah, you are still in my math gang. It's a fun gang to be in. So we're going to cancel the diagonals, we're going to cancel up and down, and then we're going to shoot straight across. I hope that helps. Have a great day.